All right, so we're going to do a review here for the end of chapter 8 and chapter 9. So we're going to go through the review sheet. Some of them I might just start and have you finish. Some of them we'll go all the way through just to get a nice overview of what's going on from the end of this chapter. So all of these were all about quadratics, so degree 2 equations. So being able to solve, and we talked about a lot of different strategies and things that we could use to help us solve. So we're going to get right into this. We'll do a few of these. Make sure you have your calculator at the ready. We're definitely going to be doing some calculations. First one is that Galileo's formula. We talked about this in some examples. Basically, just a really good example of something that uses a square in it. It says Eric has a tree house 29 feet above the ground, so the distance, the D, is 29. And they said, how long would it take a water balloon drop from the treehouse to fall on the ground? Not that they'd be dropping a water balloon on anybody, but solving for that t. So being able to substitute in 29 and then solving for t. So just realize that if all you have is a squared term, we can just get that squared term by itself. So we're going to divide 29 divided by 16, whatever that is. That's probably not going to be a nice number, but then that's what t squared is. So one of the things that we talked about right at the beginning of the chapter was how do we solve for something that's squared? We do the opposite operation, which is square root. So what we're going to be doing, I'm going to go ahead and grab my calculator here, is we're going to take 29 divided by 16, definitely a decimal number, but then I'm going to take the square root of my answer. So it's at round to the nearest tenth. So that looks like it'd be 1. That 4 doesn't cause the 3 to round up, so it'd just be 1.3. So it's going to be about 1.3 seconds. So normally I would be saying, hey, plus or minus, plus or minus. Remember, there's two things that multiply together to give you that value. Well, if it's a real life and we're talking about time, we don't want plus or minus, right? Time is only going to be positive. So we do need to think about the domain of our function when we're doing those. Okay, so for number 12, I'll have you go ahead and solve that one. To undo squaring, the x squared is already by itself. You're going to square root both sides, and again, don't forget the plus or minus. You should get 2 answers. I do want to talk about number 3. I'll get you started on 3. And again, you're going to go back and finish up the ones that I'm not doing here. So we want to get the squared term by itself. If there's only a single variable, get it by itself. So the first thing that I would do would be to add that 216 on either side. So I'll get 6z squared equals 216. Isolating, I need to divide by the 6 next. So z squared equals, looks like 36. Double check my arithmetic there. I think that sounds right. And then again, to undo squaring, we square root. So what times itself gives you 36? Well, positive 6 does, but hang on, don't just grab that first answer. Also negative 6, right? Negative 6 times negative 6. So be very aware, especially in a multiple choice kind of thing. Make sure you think about all of the possible answers right away. Don't just jump to a conclusion there. Both of those answers would make that true. All right, let's talk about this last one, number 4. This one can kind of be tricky for people in the format that it is. You have a square term. There's stuff inside with it, but we need to get rid of that squared before we can deal with anything that's on the inside. So the very first thing that I'm going to do is square root so I can get at that x minus 6. So that x minus 6 then, the square root of something squared, remember you get back to that base, would be plus or minus, right? Always 2 possibilities. The square root of 81, which is 9. There's always 2 possibilities there, right? Positive, positive, or negative times a negative. What's harder for this one is that you actually have 2 cases now that you need to solve or actually figure out. On the last ones, it was just, oh, x was by itself on the inside there that was being squared. It wasn't this time. We have that minus 6. So we actually need to do our 2 different possibilities. Either that x minus 6 is equal to 9 or x minus 6 is equal to a negative 9, being able to solve for that. So I'm really thinking about what those 2 cases would be. But each of them you solve the same way. We add 6 in both situations and get our 2 solutions. So either x is going to be equal to 15 or x is going to be equal to a negative 3. So we do have 2 different possibilities there. So positive 15 or negative 3, which is letter B. All right, well, what if it doesn't work so well just square rooting? What is our other option? So another thing that we talked about in this part of the chapter in section 9.2 was something called the quadratic formula. It's a way that we can solve to find our solutions no matter what kind of answers they are, real, imaginary, whatever it might be. So a quick little review here on quadratic formula. Basically what can happen, remember, with a parabola is either you can cross twice. Oh, I thought I switched colors there. Cross twice and we get 2 real solutions. Your parabola could just touch once where that vertex of the parabola is just a single point. You have 1, what we call a double root. Or the last possibility is that it doesn't cross at all and you have no real solutions at all. So what quadratic formula allows you to do is find any of those possibilities. And remember our quadratic formula here. Going to get rid of our writing. Quadratic formula is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. So remember, a little pop goes the weasel. The a, the b, and the c come from this ax squared plus bx plus c equals 0, our regular quadratic equation here. Remember, it has to be equal to 0 first. The a, the b, and the c are the coefficients of those terms and the constant. So we're just substituting them in. So that's the formula that we're going to be working with. So I'm going to do the first two with you, get those set up, and then I'm going to have you do 7 on your own. All right, so first thing we check is the equation in standard form, and it is, we have equal to 0. So we identify our a, our b, and our c. So the a is the coefficient of the squared term, so 5. The b is the coefficient of the x, so -3, and the c is the constant, so -8. So we don't have to get it into standard form, it already is. All right, so x equals, now can you take a moment, pause the video, see if you can plug the numbers into the right spot for me. So go ahead and plug those in, and then come back together with me. All right, so opposite of b, which would be +3 plus or minus square root b squared, -3 times -3, 9, minus 4 times a, which is 5, times c, which is -8, all over 2 times a, or 2 times 5. Now, the work that you do to simplify here, the most important thing you're going to do is this underneath the radical. That's called the discriminant. It helps us decide which of those, oops, I got rid of my pictures, which of those scenarios we have. So can you take a moment, type that into your calculator, 9 minus 4 times 5 times -8. See what you get for underneath the radical there. So we have 3 plus or minus the square root of something all over 2 times 5, which is 10. Okay, I'm hoping your something turned out to be 169. So that's the place that most people have their issue, is they mess up that number underneath. And then of course, everything from that point on is a disaster. All right, so what's the square root of 169? That's a nice number. That's 13. So 3 plus or minus 13 over 10. So where do our answers come from then? Well, we get 2 possible answers. And I'm going to kind of overuse my room here just because I'm writing a little bit bigger. The first solution is going to come from you doing 3 plus 13 and dividing by 10. Then the second answer is going to come from you doing 3 minus 13 and dividing by 10. Again, make sure you do everything in the numerator first before you divide by 10. Otherwise, order of operations, you're not going to get the right number. So 3 plus 13, and that would be 16. So 16 tenths, which can reduce down, divide them each by 2. That would be 8/5. So one of our solutions is 8/5. The other one, 3 minus 13, so -10 over 10 would simplify down to -1. So we get 2 different solutions, and they're decent numbers. So just be careful on your order of operations there. Do everything in the top first and then divide by the bottom. If you can't really simplify it, okay, then just leave it if it's not something that can be reduced. All right, let's take a look at the next one. Number 6, we're going to go ahead and do that one, and then I'm going to let you do 7 on your own. So we're going to do 6, and then you can do 7. I'll get you kind of a hint to start, but we're going to have you do that one. I'm going to get rid of this here so we have a little room. Okay, so first order of business is it in standard form? Now, when I take a look at this, I don't see equal to 0. So the first thing you're going to want to do is you're going to want to move that 10n to the other side, so add it. And you're going to want to move that -1 to the other side, so add it, and then get that equal to 0. We can't identify our a, our b, and our c until it's in standard form. So that's kind of the first step here. So our a value is 2. Our b value is 10, and our c value is 1. All right, so again, go ahead and pause the video and plug that into your quadratic formula, then come back and check. So x equals opposite of b plus or minus square root b squared. So 10 times 10 is 100, minus 4 times a, which is 1, times c, which is, or 2, times c, which is 1, all over 2 times a, which is 2 times 2. Okie doke, let's see what we got going on underneath the radical here. So that would be -10 plus or minus the square root of something all over 4, right? 2 times 2. And the something is what I'm concerned about here. 4 times 2 times 1 is 8. So 100 minus 8 should be 92. Now, 92 is a positive number. We can take the square root of it, but it's not a perfect square. So for this one, we're going to have to do a little bit of simplifying. We're going to have to try to figure out what that is. So this is where we're going to do a little scratch work. Remember how we had our little perfect square sheet? You remember your sheet that you have there? find that and look up your perfect squares, we want to write 92 as a product. Biggest perfect square times what's left over. So we need a perfect square that divides into 92. So check your list. So 4, 9, 16, 25, etc., etc. Does anything divide in there? I think 4 does. 4 times 23. So remember how to simplify these then. Do the one you can. Square root of 4 is 2. So this is the same as 2 times the square root of 3. Okay, so how does that help us? Well, now we have negative 10 plus or minus 2 times the square root of 23 all over 4. So we've simplified that radical a little bit. Now, the only other thing that we can really do, and I want you to take a peek at this, remember what these two answers are then. You've got 10 plus or minus 2 square root of 23 all over 4. Well, what that means is you're dividing the negative 10 by the 4 and the second part by the 4. So both of these are actually can be reduced with that 4. In other words, you can divide a 2 out of all of those, and we can simplify it down just a little bit. So I'm going to divide everything out by that 2. So you can actually get it down to negative 5 plus or minus 2 divided by 2 would be 1. So just square root of 23. All over 2 into 4 goes in there twice. So there's not really much else I can do with that. Square root of 23 isn't a nice number, but you could, I guess, if you wanted to write those as decimal answers, remember how we figured those out? You could type into your calculator negative 5 plus square root of 23 and divide it by 2, get a decimal answer, then negative 5 minus square root of 23 divided by 2, get a decimal answer. I don't even need you to do that. If you can get to this point, that's fantastic. So you should be able to solve if you needed to. All right, so I'm gonna let you do this last one on your own. I do want to talk about one thing first though, before we go on to the back. This is not in standard form, so you're gonna need to do a couple things. You're gonna have to distribute, and then you're also gonna have to move the negative 2 over to get that into standard form. So just be aware, then you're gonna list your ABC, and you're gonna be able to write it out. All right, so let's go ahead and flip over to the back. Let's talk a little bit about I. So we're gonna do a little work with I. Okay, so the first thing that we talked about was just simplifying with I. Remember, the definition of I is that it's equal to the square root of negative 1. So it's that imaginary unit. So I is equal to the square root of negative 1. I squared was negative 1 then. Those are some of the background things that we use. We use it to help get negatives out from underneath a radical. So for example, square root of negative 100, the very first thing that I do is I write that as a product. Square root of negative 1 times the square root of 100. And again, we're using this property where the square root of A times B is the square root of A times the square root of B. Always true. So I'm going to get that negative 1 out of there, because when I do that, then that's just I, right? So anything that's square root of negative 1 is I. And then if I can do the other one, awesome. Square root of 100, perfect square is 10. Now, remember how we talked about probably write the whole number part first. Now, for the next one, I may not have something that's left that's really easy to do right away, but I can still get that negative out of there. So always start with taking the negative 1 out. That's going to be I then. So that's great. What I have to deal with then for that 172 is like what I was doing on the other side. It's not a perfect square, but I can take out the biggest perfect square that I can. So square root of negative 1, I, and then now 172, not a perfect square, but let's see if we can find a perfect square that divides in there. So think about your perfect square list. We've got a whole bunch of perfect squares to check, and you can use your little sheet that we have. Just start dividing 172 by perfect squares. So 172 divided by 4, try that first. And I think 4 does divide in there. It's 4 times 43. Is that the biggest? Well, 43 is prime. There's no other any numbers that divide in there. So if you had tried 9, 16, 25, and kept going, none of those actually work either. So this is actually the biggest. Try to pick something that wasn't so bad. So then I can do this perfect square, right? Square root of 4 is 2. So I have I times 2 times the square root of 43. Remember, these are products. Now to reorganize, to make it a little bit easier to say, I would probably do 2I times the square root of 43. That might be a little bit easier. It's hard to put the I at the end. People get confused, like, is that the radical? Is it not? That's a little bit easier way to see it. So your whole quest here, when you're dealing with negative radicals, is to try to get the I's out of there. So for number 10 and 11, same idea. That negative 25, we're going to write it as negative 1 times 25, both radicals. That negative 4, negative 1 times 4, and then go from there. Do everything that you can. Both of those square root of negative 1s are I's. So we have I times, what's the square root of 25? Well, 5. and then we have another I, and then we have square root of 4 is 2. Multiply what you have left. So 5 times 2, there's 10. And I times I is I squared. All right, but what's I squared? Remember what we did with those? Anytime you see an I squared, we can replace that with what it's equal to, which is -1. So 10 times -1 would be -10. There's so much we can actually do if we just get the I out of there to be able to talk about that. All right, I do want to talk about 11 as well. It's kind of hitting all those big ideas that we talked about, and then we'll get into some of the other operations. Again, anything you see with a square root that's a negative, take that negative out of there. And then we're going to see if we can simplify. All right, so we've got that square root of -1, which is an I. Great. Now let's talk about what we can do with those other radicals. Now remember, for radicals, we can write a quotient and do the square root of the whole quotient, or you can do the square root separately and then divide. What you have written right now is this. You have the quotients separately, but sometimes it's easier to think of it as what that entire quotient is first and then do the square root. I know sometimes we say, well, let's split it up, see if that's easier, but sometimes it's not. Sometimes together is better, because can't we do 250 divided by 10? That's I times the square root of 250 divided by 10 is just 25, and that makes this a whole lot easier. Square root of 25 is 5, and we're left with 5 times I. So it really does depend on what expression you have. If it's easier to do the quotient first, like what I just changed it to, great. If it's easier to do them separately, do that. We really do have that option every single time. All right, let's talk operations with I. And again, I'm going to let you do some of these on your own. But for 12 and 13, you are just putting together like terms. So I'm going to have you do 12. 13, I just want to remind you of something. When you're subtracting, remember that goes to everything in that second set of parentheses. So 8 plus 9i minus a negative would be plus positive, so plus 4. And then minus I, that's the one that people are probably going to forget. Just be careful, it goes to both of those. Then you can put your like terms together. The reals with the reals, and imaginary with imaginary. So 8 plus 4, that would give us 12, right? And then we'd have 9 minus 1, so careful on that, plus 8i. So we're looking for putting together real and imaginary parts, either adding or subtracting. It's just careful on the subtraction for that distributing. All right, let's talk multiplication and powers of I here for the end. So multiplication is interesting because it's just really doing what you would normally do. It's just that anytime we see an I squared, we can replace that out. So for 14, you're going to do exactly what you think you should. Just distribute that 9i. So 9i times 8 would be 72i. And then 9i times -3i. So 9 times 3 is -27. And then I times I would be I squared. Now, if this was just regular algebra and you didn't know what I meant, you'd be done. Those aren't like terms, can't put them together. But we do know something else. We do know what I squared is. I squared is equal to -1. So we have 72i minus 27 times a -1. What a lot of people think when they do I squared is they just think opposite sign. So whatever the sign is, when you plug in an I squared, it's going to become opposite that, because that's what happens when you multiply by -1. So -1 times -27 is 27 positive though, right? Now, when I write my final imaginary or complex numbers, I should say, I usually write the real part first, so 27, and then the 72i. For me, that's an easier way to write it. It's like that A plus BI format, so that's something to think about. I'm going to let you try 15. It's just a regular multiplication. I'm going to let you do 16, because that's a binomial times a binomial. That means you are going to do FOIL, which is what I'm going to help you with number 17 here. When you're going to do this, you're going to do first, outside, inside, last, which is actually exactly what we're going to do on 17. 7 minus 6i squared. Remember what it means to square something. That means you're multiplying that base times itself. So isn't that really just FOIL as well? I know a lot of people miss that, but that's all that really is. It's a binomial times a binomial. So first, 7 times 7, 49. Outsides, so 7 times -6, so minus 42i. Insides, a -6i times 7, so another -42i. And then last, careful on this one, a lot of people miss this. Negative times a negative, so plus 6 times 6, 36, and then I times I squared. For some reason, people, they get so worried about the i's, they forget about the number part. So there is a coefficient there to multiply. Okay, like terms time. So put together your i's. So 49 minus what, 84i? And then we have this plus 36i squared. But again, what's I squared? -1. That's actually a numerical value. That's -36. So anytime you see an I squared, think -1. Now I can put it together with that 49 to get my final answer here. So 49 minus 36 would put me at 13, and then minus that 84i. So when we're putting those together, we're always thinking about what those like terms would be. So FOIL is just normal, but then remember with your I squared, you're going to have to deal with those powers of I. Okay, last ones to deal with. Let's do the powers of I here. Remember we talked about, we had a nice chart that we filled out. If you have that in your notes to look at, that would be really helpful. Remember, you're looking for the biggest multiple of 4 and what's left over. You can always count up if you need to, but I to the 19th, we want to break it down so we can see what part is left over here, so we can simplify it down to one of those 4 answers. So I to the 19th, we try 19 divided by 4. Remember, multiples of 4 are always 1. When you do 19 divided by 4, just going to show you this on your calculator here. So 19 divided by 4, you get 4.75. So the 0.75 is what's telling me that this doesn't divide evenly. And how many we have left over? We have 3/4 left over, or 3 left over. That means the biggest perfect square less than 19 that is divisible by 4. It's not 18, it's not 17, it's actually I to the 16th, right? How many more i's do we need to make a 19? 3 more. So our kind of shortcut was looking at what was left over on the calculator. There's 3 parts left over, so that means there's an I cubed left over. You can think of it that way. I to the 16th is 1, right? Any multiple of 4 is 1. That's going to leave us with I cubed, and you have to just remember what I cubed is. So we went through our first 4 powers. I to the first, I to the second is -1. I cubed was -I, and I to the fourth is 1. I squared times I squared. We developed those. So this is the same as what I cubed is, so -I. So we multiply those together, it's equivalent to -I. Your answers are always going to be, oopsies, where's my -I? Right there, letter B. Your answers are always going to be one of those 4. You just have to figure out where you are in the cycle. Always try dividing by 4 first. If it's not divisible by 4, it's going to either have to be then an I squared, or an I cubed, right? So we just have to figure out where we are in the pattern. So I'm going to have you try number 19 and number 20 and see what you come up with. And then you can check your answers on all of these, but this should be a really good overview of what we did in chapter 9 with that section 8.7 on imaginary.